Alright, we are in AP Stat. We are in Chapter 6, where we're looking at standard deviation as a ruler and the normal model. We're going to go over some practice problems here. This is the end of Unit 1, just to give you some practice problems that we can look at. Again, if I'm moving too fast for you, you will need to pause these videos and then come back in, restart, so you can write everything down. But a company selling clothes on the internet reports that packages, right, they're being shipped and they have a median weight of 68 ounces and an interquartile range of 40 ounces, right? The company plans to include a sales flyer weighing 4 ounces in each package. What will the new median and interquartile be? And if the company recorded the shipping weights of these new packages in pounds instead of ounces, what would it be? This is the idea of the problems. When you add something to them or multiply something to them, what happens to that medians and the interquartile range? So, by adding 4 ounces, all right, it will affect only the median and not those standard deviations, right? So the company includes a sales flyer weighing 4 ounces in each package. They are adding 4 ounces to each package. Since it's each package, if everything goes up 4, then your mean and your median will also go up 4 is what it's saying. So that will change. But none of your variations, your interquartile range when you're adding, your standard deviation when you're adding, none of that will change. So the interquartile range is still going to be 40. It just basically moves everything up 4. So that's all that will change. But it says changing the units is either dividing or multiplying in order to make that happen. And when you are dividing or multiplying, when you are going from pounds to ounces, because it says the new package instead weighs these new packages in pounds instead of ounces. If you're trying to do that, we're actually going to have to divide to make that happen. So if you divide, that means you can divide the median if you're dividing everything by that, because you're altering the units. So now we have the new median of 4.5 pounds, but when you multiply or divide each item, you're also changing your variations, which is your interquartile range as well. So that also must change to 2.5 when you're doing it. Taking a look at the next one. A company's customer service hotline handles many calls relating to orders, refunds, and other issues. The companies that record this indicate that the median length of calls to the hotline is 4.4 minutes with an interquartile range of 2.3 minutes. If the company were to describe the duration of these calls in seconds instead of minutes, what would it be? All right, so more than likely, if I'm altering every single one from minutes to seconds, that means I'm either multiplying or dividing by something, which means everything is changing, the median and the quartile range. But in Part B, it says, in an effort to speed up the customer service process, the company decides to streamline the series of push-button menus customers must navigate, cutting the time by 24 seconds. What will the median be and the length be? All right, so if they're cutting it, I believe they're talking about subtracting 24 seconds from it. So taking a look at this, in Part A, I'm changing the units. I'm changing the units either to multiply or divide, and it turns out I'm multiplying because I'm changing it into seconds. That means the median has to change as well as the interquartile range, because that is your sense of variation, giving us our two new median and quartile ranges. But by cutting, we are subtracting 24 from each item, which in turn will impact the median still, so it will decrease. All right? So it decreases the number of seconds because it says we altered it by changing it into seconds. So now I'm subtracting it from the seconds, but my interquartile range is unchanged. I'm taking a look here at this one. Here are the summary statistics for the weekly payroll of a small company. Lowest salary, right? We got that. Mean salary, median salary, the range, that's low to high, the interquartile range, Q1 and Q3 distance, right? We have those. Or sorry, at least I have the Q1, and I have the standard deviation. So they gave me a ton of stuff here. Do you think the distribution of salaries is symmetric, skewed left, or skewed right? Is basically what we have to figure out by reading this. Between what two values are the middle 50%? Well, that one we can stare out easily. The interquartile range is between Q1 and Q3, and if I know the range is this, and I know that that's one quartile, basically we can set up an equation to solve to find that third quartile to see where the middle 50% is from. Suppose businesses have been good and the company gives every employee a $50 raise. That means if every employee gets a $50 raise, they want to know what's being bumped up and what isn't being bumped up, basically, and tell us why. And instead, suppose the company gives each employee a 10% raise. Now we're altering everything along the way. So, taking a look at what each item is. So taking a look at this, it says, do you think the distribution is skewed left, skewed right? Well, the distribution of salaries in this company is skewed to the right because the mean salary is 700. Where is it? The median is 500. Normally, if the mean is higher than the median, which in this case it is, there's probably an outlier pulling it down to the right. All right. If they are almost exactly the same, then it's pretty normal and symmetric, right? But because the median or the mean is higher than the median, there's probably an outlier pulling it down towards the right, which means that that is skewed to the right. Here's the equation and the work that I was talking about. We know the interquartile range, and I know Q1. So if I add that over and I plug those in, I figure out that that third quartile is basically 950. And if that moved too fast for you, I apologize. But 50% of the salaries would be in between there. You can pause that video and take a look at it. Part C, I'm literally going to be raising $50 to each one, so I'm adding $50 to it. So if I'm increasing everything by 50, the minimum, right, every value changes except for our variation. So I'm not changing the range. The range is still 1200. I'm not changing the standard deviation. I'm not changing the interquartile range either. Those are all the same, but everything else, all right, should be add 50 to it basically. So that's basically what we're doing there. We shifted it all up. And because 10%, that's like multiplier. So if I'm multiplying everything by 10%, that's what I'm basically doing with each individual item, including standard deviation, including the range, including the interquartile range. Everything gets bumped up with that one. Taking a look at this one, specialty foods company sells gourmet hams by mail order, and the hams vary in size from 4.15 to 7.45 pounds with a mean weight of 6 pounds, standard deviation of 0.65 pounds. The quartiles have median weights of 5.6, 6.2, and 6.55 pounds. All right, so it says the quartiles and the median weights are, so I'm going to go probably with 1, 2, or 1, 3, and there is the, I guess the middle could is probably the 6.2. But the point is, find the range in the interquartile range. Okay, the hams vary in sizes from that to that, so that's probably the low to high. That's the mean and standard deviation, right? So they're giving me enough data. The quartiles and the median, right, are listed there. Do you think the distribution of the weights is symmetric or skewed? So you need to compare the mean and the median to see where it's looking like and why. If these weights were expressed in ounces, all right, which means now I'm changing from pounds to ounces, which means I either have to multiply and divide. What would each item be? So because I'm doing that, everything would need to change. When the company ships these hams, the box and packing material add 30 ounces. So now that I've changed everything to ounces, I can add 30 to everything, but that won't change my range, my interquartile range, my standard deviation when I'm changing these. And then one customer made a special order of 10-pound ham. Which of the summary statistics of Part D might not change if that data value were added to the distribution? So let's take a look here and fight our way through. The range is the max minus the min, so right there it is, right? And they told us the high and the low. The interquartile range, okay, this went in order. Q1, Q2, Q3 with the median being right in the middle, so basically you subtract those to find the interquartile range and you are done. Part B, do you think it's skewed or not? Well, the distribution of hams is slightly skewed to the left because the mean is lower than the median. So the mean, with a mean is 6, and that being 6.2, it seems pretty close. So some kids are like, well, you know what? They're pretty close to each other, right? But what's the standard deviation? The standard deviation is 0.65, right? So that's one standard deviation away. So it's not like the standard deviation is, you're looking at it and comparing it, but more than likely the mean is lower, which means there might be some outliers. So I would go with slightly, but not a much, but slightly skewed to the left, pulling it down. All the statistics for Part C are multiplied by 16 because we're changing them from pounds to ounces. So we're kind of making the units smaller, which means there will be more of each, so you have to multiply every single item, including the ranges, the interquartile range, the standard deviation, all by 10%. Was it? Is it 10%? Let's see here. Nope. Sorry, we are multiplying by 16 to change them into ounces. Excuse me. Then we have part D. When the company ships the hams, they're adding 30. So you take all those ounces that you just found, but you add 30 to everything except for the standard deviation and the ranges, the interquartile ranges, because those are variations, so they stay the same. And then part E, one customer adds a special order of a 10-pound ham. Which of the summary statistics might not change? 10-pound ham were added of distribution. The mean would change. All right, because now I'm taking 10-pound ham and putting it on there. Well, a 10-pound ham, as a result, would be, what, 160 ounces, which the standard deviation would increase everything because I'm drawing it down. So it's skewing everything farther to the right because that's a pretty hefty weight of them. Because as you're looking at this, they're looking at the average pounds, right? The hams go from 4 to 7 pounds roughly. You're telling me that we're slapping on a 10-pound ham, so that's outside. It's an outlier pulling everything down towards the right. So what this is saying is the standard deviation would increase since 10 pounds is far above the mean. The overall spread of the distribution would also increase. The range would increase as well. The median quartiles may not change though, because it's only one item that's pulling it all down. Okay? When I come back here, we will take a look at the SAT and the ACT to see how they also compare.